Okay, today we're going to look at 1.3, and that's intersection of lines. Okay, and we're going to think about how many ways can a pair of lines intersect. So really what happens is you either have a Cartesian plane, and you're going to have, like I was saying before, when we talked about this before, was you can have two lines and they intersect at one point, okay? And then you can have two lines and they never intersect because they're parallel, okay? And we're going to look, so they can be parallel and never intersect, or you can have two lines and they actually sit on top of each other, and then means there's an infinite amount of solutions. So we're going to look at equations of lines and what needs to be the same, what needs to be different. And again, we're talking about slopes and y-intercepts and how they're related to how many points of intersection they are. Okay, so you can look at two lines and tell me how many points of intersection there are just by understanding what the slope means and what the y-intercept means. Okay, so we're going to take a look at the lines that we have here now. Okay, and these you can also go on Desmos and you can graph these yourself as well on there, and you can see how they work. Alright, so we're going to rearrange the first line again into a slope intercept form so we can find out our slopes and our intercepts. So this is y equals negative 2x plus 5. Okay. The other line, when we rearrange this one, we'll have negative 2y equals negative x plus 10. Divide everything by negative 2, and we'll have 1/2 x minus 5. Okay? So we've got our two lines, and all we've done is rearrange them to put them into slope-intercept form. Okay? And, oops. Let me erase that. Okay. So the slopes of the two lines, we've got line 1, okay, and line 2, and we'll keep it in the red and the blue for the rest of it. Okay, so line 1, my slope is negative 2. Okay, and for line 2, my slope is 1/2. Okay. The y-intercept for both of these lines, for the first line, the y-intercept is 5. Okay. And then my y-intercept for the other line is negative 5. Okay, so we've seen that, and now we can go ahead and graph these lines. We'll graph the red line first. Okay, and I don't even need the equation anymore because I have the y-intercept, and the y-intercept is 5 for the red line. And my slope is negative 2. And remember, negative 2 is over 1, so it's rise over run. So we do 1 for the run and then 2 down for the rise. 1 for the run, 2 down for the rise. 1 for the run and 2 down for the rise. Okay, and we can keep going. And we can draw our line in. Okay, and again, I'm going to do my best here. I don't have a ruler, but you guys should be using your rulers for these. Get them nice and straight as you can. Okay. For the other line, we're starting at negative 5 for our y-intercept, and our slope is 1/2. Okay. So negative 5. Our slope is 1 over 2, so now we're going over 2, and we're going up 1. Run is 2, there's 1, and you can see where they intersect. Okay? So, what you should be getting out of this is that how many solutions are there to this system? That's correct. There's one solution. And that's the point of intersection. Okay. The M is different. In our case, the B is different as well, but if the B is the same, there's still only one solution. If the B is the same and the M is different, the B is your point of intersection because the B is shared by both lines. So as long as M is different, okay, B could be different or the same. Okay, if it's the same, it is the point of intersection. But if it's different, then there is another point of intersection. What's important here is that M is different. If the slope is different, you've got one point of intersection, as long as the slopes are different. Okay? And that's why I'm saying you just need to look at the lines. So right away, when I look at this, two equations here, I see here -2 is my slope, 1/2 is my slope. Therefore, that means that there has to be one point of intersection. No more, no less. There's going to be one. Because the lines aren't parallel, they'll cross each other at some point. Okay? If it was +5 and +5, they would cross at +5. If they were, in this case, they're +5 and -5, so that means that point of intersection is somewhere else. Okay? So again, just by looking at the lines, you can tell how many solutions there are to the system. Okay, just by looking at the slope and the y-intercept. Okay, we'll look at case B now. And this one's already in slope-intercept form for us, so there's nothing to do. We can change the second line here, and we'll change this one up to B. I'm just going to go straight ahead and do it. I'm not going to do the different steps in between. So y equals 2x minus 4. Okay. And we get our two equations there. So, again, going to our table here, and we're looking at the slopes of the lines. For the slopes of the lines, for the red line, we're going to have 2. And we're going to have 2 for the blue line as well. Sorry, let me change the color on that one. So we have 2 for the red line, and we'll have 2 for the blue line. Okay. For our y-intercepts, they are different in this case, and for the red line we have 3, and for the blue line we have -4. Okay. So now we see that our slopes are the same. And what does that mean? Remember, the slope of a line is the steepness of the line. So how steep it is, what direction it's going in. So if the steepness is the same, then that must mean that the lines are parallel. Okay? So when we graph these, and we'll see what we get here. So for the red line, we have a slope of 2 and a y-intercept of 3. So we can graph that one in the red. So we have a y-intercept of 3. And remember, 2 is the same as 2 over 1. So it'll be 1 over and 2 up. Or 2 down and 1 to the right, to the left, sorry. And we can draw that line in. And again, my line is not perfect. For the other one, we have a y-intercept of -4, which is down here, and still the same slope. So 1 over, 2 up. 1 over, 2 up. 1 over, and 2 up. And you can see, if I keep drawing these out, will they ever meet? No, because the slopes are the same, so the steepness of the lines are the same. That means they're parallel. Okay? So for these, there is actually no solution. Now here it's important because the slopes are the same, but you also have to have different y-intercepts. Okay? If the slopes are the same and the y-intercepts are the same, we're going to look at that situation and see what that is. But if the slope's the same, the y-intercept's the same, actually the line is the same. So it's a different case altogether. So for no solutions, you need to have these two conditions, 1 and 2. Same slope, but a different y-intercept. It has to be that way. Okay? So again, looking at this line right now, I'm looking at it, I analyze, my slope is 2, my slope is 2. Now I know the lines are parallel, my y-intercepts are different, okay? And then I can say there's no point of intersection between these two lines, okay? The third case, C, when I rearrange this one, even though this doesn't look like it's the same at first glance, but when we do this, y equals negative x plus 3. And then for the other line, when I rearrange this, I get 2y equals negative 2x plus 6 as well. And then when we divide everything by 2, we end up with negative x plus 3. So even though it didn't look like the lines were the same, but they are the same. They're the exact same lines. And this, if they're the exact same lines, you get a slope of negative 1, a slope of negative 1. Okay? Scrolling down, our y-intercepts end up being 3 and 3. Okay? And then our slopes for both the lines is going to be, if we draw these ones, we get 3 for the y-intercept, 1 and down 1, 1 and down 1, or you can go 1 to the left and up 1, okay, and we can draw our line in. And both lines sit right on top of each other, okay? And if both lines sit right on top of each other, they are the same, and then that means that there are an infinite amount of solutions. Okay? In this case, we need the same slope. These are my conditions for this to happen. And same y-intercept, okay? So same slope, same y-intercept, they have to be the same lines, they're on top of each other, and there's an infinite amount of solutions. Okay, that's our third case, okay? And it's all about analyzing the slope and the y-intercept of a line, like we've always been doing. We've always been looking at the slopes and the y-intercepts of lines. If there is one solution, you have one point of intersection, M is different, okay? B could be different or the same. If it is the same, you've got that point of intersection at the B value. It has to be there. If there's no solution, the slopes are the same, meaning the lines are parallel, but the B values need to be different so that they're not on top of each other. Okay, and then that gives me no solution. All right, or the lines could be the same, even though they don't look the same when you start off, like we did in our example C here. When you rearrange it to put into slope-intercept form, then you can see where the slope is, where the y-intercept is, and then you can see the same slope, same y-intercept. So they sit on top of each other, and there's an infinite amount of solutions. Okay, that's it for this one, and I'll do up the next one in a bit, and you can follow a link to that one and see page 2 for the lesson, okay?